Alright, silly people, here's the situation. This time we're going to be making a user-defined function which is going to calculate factorials using integer variables, not floating point ones, and then also do the same thing for floating point variables to then calculate the factorial of 200 in a couple of different ways. So uh, let's just get into it. We won't even need to import any packages for this because we're just going to define the integer version of the factorial, which I'm going to call factorial int. It takes an argument n, and then it's going to check if n is equal to 0, then it returns 1, and I'm doing this because I want to just do recursion for this, so otherwise it returns n times factorial int n, and then make sure that it's all wrapped up in an integer, just so it doesn't become floats at any point. And that's going to be alternative to the float version of the same program, which I'm just going to call factorial FL, which also takes an argument n. And then right here, the first thing I'm going to do is make n a float, so n equals float n, and then pretty much the same code at that point. If n is equal to 0.0, then return 1.0. Otherwise, it's going to return float n times factorial float n. And then we can print out what the integer factorial of 200 is, and also the float version of 200, and see what we get. What did I do wrong? Oh yeah, I need to actually make the recursion part of the recursion. Put -1s in the function calls. Minus 1.0 for the factorial one, but then that should be good. Aha. So the answer on the top looks pretty correct because it actually just does the factorial with integers, and it uses all the integers it can, and ends with a bunch of zeros because it multiplies by a bunch of values of 10. But the float version of the function actually returned infinity, and that's just because integers are stored differently from floats in Python. 200 factorial actually exceeds the maximum value a float can take in Python, where the integer factorial ends up using all of it, and I think it's even the correct answer, so interesting.